No number there, but there really is. What do we know is actually there? A 1, right? A -1. Okay, so my first question is, this is a letter, which is A. That's our A value, which is referred to as our what? Amplitude. Okay, so that's called our amplitude. And I discussed this yesterday with a bunch of you. Amplitude is always positive. So if you're going to tell me what the A value is, it's +1. Okay, amplitude is height, and height is always positive. All good. Now, the number that's always added or subtracted over here, that is your C value. All right, C value. There's an A value out in front, which is amplitude. And then at the end, you're going to add or subtract a number sometimes. It's called your C value. Now, this could mean a couple different things. This is your midline. That's the midline, whatever that number is. All right, so when anybody says, oh, plot the midline, I'm going to plot whatever that number is. Also, it's also our shift. Okay, it's also our shift, which +4 means, where am I going? Up or down first? Up, and then how many units? 4. So this curve is going up 4 units. Good. Now you notice I skipped over a letter in the alphabet. That's coming today. Okay, I'm going to start putting a B value next to the X, and that's going to screw everything up. All right, so if we don't get this down, oh boy, wait till I throw in a B value. All right, next up, let's fill in some of our stuff here. I told everyone here, it was yesterday, please find the min and the max first. Please find the min and the max first. So let me get to somebody who was here yesterday so that can help us out. I got the wrong one. Who's 10 in here? Who's 10? Oh, Juliana. Yeah, you were here yesterday. Ready to rock and roll?
Yeah.
Oh, I don't even. Let me get your mug shots here. No, that second period. There's third period. Yep. Yep. Okay, you ready?
Yeah.
All right. Before I taught yesterday's class, Juliana, you would have said the min and the max were what? -1 and 1, because of the number out in front. Everybody was here for that. All right. So my old max was 1, and no, God, I'm teaching, for the love of God. If somebody's in trouble here and interrupting my teaching, John Carlino. Sure, you got it. Yep. All right. Gabriella, Counseling Center with your Chromebook, they said. Okay, so head on down. Okay, Julianne, back to you. 1 and -1. But yesterday, now we shifted up 4. So the max, I add 4. What's my new max? 5. And to the min goes up 4. What's my new min? 3. So there it is. That's how I find the new min and the max. So 3 is my minimum. 5 is my max. Good there, everybody. All right, let's find the rest now from people who are here. Let's go range. Julia, you want to just take care of the range now because you did min and max already? Always brackets, yep. 3, 5. Make sure the smaller number always comes first. Vertical shift. Up, down, how many units? Let's go. Up 4. People who were here yesterday, I do not accept +4. You have to tell me the word up or the word down. You putting +4, I don't even know if you know if plus means up or down. Seriously. So up 4. Yep. How about anybody else here? Oh, Chris, Jesus. Oh, Friday. See, I don't need to be here. Candace, here we go. Amplitude. What's the number out in front? -1. Okay. Oh, be careful now. Remember, amplitude's always positive. So it is 1, not -1, just 1. Everyone good? Amplitude is always positive. Let's keep going to some other people here. Here yesterday. Let's keep going. 1, 9. Brennan, you were here. Midline. Y equals whatever your C value was. Again, midline. That's my C value. And then everybody, period is always ending at until today. Hopefully you get this. I'm changing that today. What's up, Grayson? Roll. Hurry up. Let's go. I got some greatness to do here. All right. All right. Everybody good now? Just go. We don't need to make it a scene. Everyone good? All good? All right, now the graph. It's probably the most important part. But if you have all this information, we should be good. All right, let's talk about how to graph this bad boy up here. Sierra, you ready? Yeah, you are. Are we graphing sine or cosine? Sine. Where does sine always start? At the midline, which always was 0, but yesterday we said we're shifting it up 4. So now I got to go 1, 2, 3. That's where it's going to start. Midline to where? I'm talking basic sine curve. Max, right? Everyone, yes? Midline to max. But that's why the negative is there. You're actually not going to go to your max. Where are you going to go? Minimum of 3. 1, 2, 3. Then where? Midline, which we said was 4. Usually now it would be where? Minimum, but the negative says flip it to the max of 5. Why am I just blanking? There you go. And then going where? Midline. Finishes at the midline. There it is. And you can use your calculator to check. There's no reason why we're just using the calculator to try to graph this. All right, no. All right, everyone good. There's my review yesterday. I don't have time to do another one. All good. Okay, here's what's going to happen today. We said we skipped a letter here. You know what the A is now. You know what the C. Now you are going to see a number with the X. And that's going to be called our B value. And hey, and you know what's going to change here eventually? Have I ever changed these numbers on these radians on the x-axis? Well, it's going to change today, though. Okay, it's going to change today. Henry, you ready, boss?
I guess.
You got any big week? Don't guess. Yes, I'm ready to roll. You got any big weekend plans? Going out to the club with the boys?
No.
No? Just balled up in the corner of your room, wishing you had friends?
Well, I'm working.
Oh, where do you work, stud?
I work at the Beverwick. It's a retirement home.
I know what it is. Thank you. I know. I just don't live in a little closet over there and come out during class. Yeah. Yes, I am a functioning adult. Yes, I know. Nice. All Saturday and Sunday?
Today and tomorrow.
Oh, okay. Got Sunday off. How many hours do you work?
4.
What do you do over there? You help them out, or do you?
I'm a waiter.
Oh, that's nice. That's
like food. Yeah.
Have you dropped it before?
One time.
It was like you dropped it on the old people?
No, it was on the floor.
Okay.
It was like one time, though.
A lot of Jell-O being served
No.
over there? No, really?
Pudding.
Pudding. Is it an assisted living home, or is it just
Well,
like a retirement?
it depends. Sundays, I'm at the assisted living, and then Fridays and Saturdays, I'm like at the normal place.
Nice. Do you just sit down and like start playing some games with them or anything? Because they love that stuff.
I just give them their food.
Okay. Are some of them mean to you?
Yes.
They do, right? Yeah, I'm sure.
Are you friendly to them?
Yeah.
Yes.
That's tough though, isn't it? When they're mean to you and you got to be just
It is.
friendly and smile on the way back.
Mm-hmm.
Okay. Good. Any of the ladies trying to hit on you? The old ladies?
Sometimes.
Yeah. I could see you're a stud. I could see that. This guy. Getting guest passes to senior ball for a 60-year-old. Nice. All right, moving on. Good weekend coming up for you. Good. All right, first up, here's the graph of 3 cosine x. Here's the graph here, 3 cosine x. Everyone it goes up to 3, down to -3. We're used to this, right? Starts at the max, goes to the midline, minimum, midline. This is typical cosine for us, right? Typical cosine. All right, now look what I'm going to do in part A. I don't want you to use your calculator. I'm going to show you what the graph looks like. Now we're going to graph on the same graph, 3 cosine 2x. Notice the difference. See where the 2 is. We have never seen that before. I have never given you an equation to graph where there is a number in front of the x. So you ready to see how it affects it? First up, please graph a point at the maximum. This is where still going to start at the max. Okay, it's still going to start at the max. Again, we are graphing 3 cosine 2x right now. Okay, now, ready? Put a point halfway in between 0 and pi over 2. Put a minimum at pi over 2, -3. Go back to the midline, but it's going to be halfway in between pi over 2 and pi. So put a point on the midline halfway between pi over 2 and pi. At pi, put a maximum. Whoa. We're going to keep going, but I'm going to stop right here. Do you guys see we already graphed a full cosine curve? And it just ended where? Not at 2 pi anymore. Where did it end? At pi. Oh, wow. We just did one full curve, but it only took us to pi this time instead of 2 pi. All right, let's keep graphing a couple more points. Midline, halfway in between pi and 3 pi over 2. At 3 pi over 2, can you graph a minimum? Can you graph a midline in between 3 pi over 2 and 2 pi? And then finally graph a maximum at 2 pi. And go ahead and draw this graph in. That is 3 cosine 2x. Make a note of it, please. Make a note of it so you know, because I'm going to do another graph here in a second. 3 cosine 2x. Notice a little bit of a difference now. How many cosine curves do you guys see? All the way out to 2 pi. How many cosine curves do you see? How many? Go ahead. Say, yeah, how many do you see? You see one. There's one curve. And then a second cosine curve. So there are 2 full curves here for part B. 2 full curves. That's interesting. What number did I put in front of x? Oh, there's a, I wonder if that's a coincidence or not. That because I put a 2 in front of x, I saw 2 of the curves. All right, next up. Now I'm going to do with 1/2 in front. Now I'm going to do with 1/2 in front. And you know what I'm going to do here? We're good. Let's go. Here we go. We're good. Should have these out really bad. Pencil. Do this in a different color, please. This next graph, do it in a different color so you can definitely see it between the other 3 for me. Yep. Okay, everyone ready for the next one? What is 3 1/2 x going to look like? All right, ready? Take your colored pencil. Still start at the max. We will still start at the max. At pi is your midline. At pi is your midline. And at 2 pi is your minimum, -3. That's all I'm giving you. Ready? That's all you're going to see. To 2 pi, that's all you're going to see. How much of the curve did you see? Only half of it. You only see half of the cosine curve there, huh? So we only see a half curve. Huh. That's interesting. So do we see the number next to the x has something to do with how many of the curves we're going to see, right? Okay. Next thing I want to talk about, we have really not talked about, and you don't have to jot this down, I just need you to lock in. We have really not focused too much on that vocab word, period. Because anytime you heard that word, you wrote in 2 pi. Well, it ain't 2 pi anymore. It's not 2 pi. Look at the first curve I had you guys draw in there. 3 cosine 2x. How long on the x-axis did it take to make the first curve before it started repeating again? Where on the x-axis did it start repeating again? Let me say that again. My red one up here. Where on the x-axis did it start repeating itself again? Because it's not 2 pi anymore. Anybody see where it was? Where did it start repeating, Tyler? At pi. Everyone agrees? This curve would whoop up. Once I hit pi, it started repeating again. All right. Here's the challenge now. Where would this start repeating? Because it's not on the graph, but I want you to think about it. Where would this curve start repeating itself? Well, you told me we saw half of it at 2 pi. If I kept going, where would it end? 4 pi. Everyone see that? So this curve had a period of pi versus this one had a period of 4 pi. Let's flip the page now because you answered some of the questions already.
Oh, I have a question. When you draw that line into the half one, can I just draw a straight line? Or does it have to be curvy?
It's a cosine curve, Tyler. It's cosine. You're only going to see half of it, so it's got to still be curved. It's not a line, it's a cosine curve. Okay? All right, ready? Let's answer these questions here. Don't worry about the frequency part yet. We'll fill that in a second. Period. 3 cosine x. You might have to flip back and forth or take a look up here. That was my original graph I had up here, everybody. That was my original graph. Where did it end? Where did it end before it starts repeating again? Where would it end? No, actually, no. I got too many yellows here. I got to get back to my numbers. That first curve, where did it end again? Miles, where did it end? 2 pi. So everyone write in where it said period there. 2 pi. All right, the red one I have up here, the second one we did. Where did it start repeating itself on the x-axis? Where on the x-axis did that one start repeating? Samir? Pi. So period for that one was pi. And for the last one you guys did in colored pencil, we said, hey, I can't see it start repeating, but I know if I see half of it at 2 pi, where's it going to finish on the x-axis then? Henry?
4 pi.
4 pi, correct. All right, let's start talking about this number next to the x now. Nothing's there, but what's really there next to the x in this one?
3. Oh,
Next to the x. Nothing's written there, but we know there's what there?
1.
A 1, right? There's a 1 there. There's a 2 here, and there's a 1/2. Does everybody see the smaller that number got? What happened to our period? The bigger it got, right? The smaller this number, so from 1 to 1/2, it went from 2 pi to 4 pi. That number, let's give a new vocab word. That is your B value. Everyone ready? It's called the frequency. The frequency, okay? So before you had amplitude and shift. Now this number here is going to be called the frequency, the B value. That is your B value now. So for each of these, frequency here is 1. Julia, what's in place of the B value in part B here, this equation?
2.
2. There's my B value. And what's my B value for the third equation we graphed in colored pencil there, Candace?
1/2.
1/2.
Does it always have to be positive like the
It will be. It will never have a negative there. Trust me, I will not put a negative there. It will always be positive, okay? All right, now there is a relationship between what the frequency is and what the period will be. And it is a formula, kids. It is a formula. It's a short one that you need to memorize. Here it is. Period. How long it takes to repeat will always be 2 pi, always 2 pi, over divided by, ready? The B value, the frequency, always. That's how you calculate the period of a graph. That's how you calculate how long it will take before it starts repeating. You take 2 pi always and divide it by your B value. Okay? That's something that's something you got to memorize. The only thing I'll have you memorize here as far as formulas go. Okay, let's see how we can do here. This next 3 problems, find the period. Okay, I threw a lot of stuff in there, a lot of numbers. I just want you to find the period. Okay, who's going to help me here on the first one so we can get going? Julia, just give me the formula for period again before you help me fill it in.
2 pi.
Good. All right, I got a couple numbers up there, Julia. Just mess with your mind. Which one is the B value, though? 4. 6 is my A, called my amplitude. So 2 pi over 4. And I'd leave, what's your calculator's giving you when you do 2 pi over 4? Good. I want it simplified. I'm glad your calculators are giving you the simplified version, which is pi over 2. Everyone put that in their calculator, 2 pi over 4, and you're getting pi over 2 back. Yes, no? We're all good? Again, that means this graph would start repeating at pi over 2. All right, next one. Who's up with me here? Grayson, good job. Jesse, good job. Let's try this again. Good old Friday. Kaylee, you're going to come up big here for me. Period formula first, Kaylee. Good. 2 pi over b. 2 pi. All right, I got a couple things rocking in that formula. What's the b value, though? Pi over 3. And thank goodness we have those calculators that'll do it for us. I just got to make sure you plug it in correctly. When you have that, Kaylee, let me know. You got 6. Yep. Sometimes it doesn't have a pi. Sometimes we will put no pi's on the x-axis. 6 units it takes to repeat again. 6 units. All right, final one here before I get really hyped, more than I am now. Sierra, period formula. I just want to keep saying it. I got a lot of things in that formula, but there's only one b value, which is what? 2/3. Yep. No pi with it. So when you're ready, 2 pi divided by 2/3, let me know. 3 pi. Good job. Okay. Questions about how to find the period? Because now I'm going to put everything together here to end class. Guys, anything? I love this part. This puts everything together. All right, ready? We're going to graph these now. No calculator, though. We don't need the calculator to graph these. First thing I want to do, though, notice it's a blank graph, isn't it? It's a blank graph. All right. So first thing, let's make it look like ones we're familiar with. So here's your y-axis all the way over to the left, and about halfway in between is going to be your x-axis. Let's start with the y-axis because I think everyone's more familiar on what needs to go on the y-axis. So let's start with the y-axis. Think about when we graph cosine, sine, cosine, and sine. And I go around and I say, where does it start? Where does it go? What 3 values do you think need to go on my y-axis? What do I always graph with sine, cosine? I want to say 10. We're not doing sine and cosine. What 3 values have to go on my y-axis? Go ahead, Wes. What do you got? I got to find the max. Has to go on there. Keep going, brother. The min and the what? Midline. Darn right. Okay? So those are the first 3 values I'm going to find with somebody. And those 3 have to go on my y-axis. Okay? You guys have had practice on this. All right, Cameron. Here yesterday or not, doesn't matter to me. It actually doesn't matter here. Notice there's no plus or minus, right?
Yeah.
So that means the midline is 0. So everybody, midline 0. There's the midline. All right, Cam, is there a number out in front, an A value?
1.
There's 1. So how high is it going to go?
1.
And down to?
-1.
-1. There you go. Everyone see? No A value. Well, there is an A value. It's 1, so that goes up to 1, down to -1. How you put these on your y-axis is up to you. Obviously, 0's got to be here. That's always 0. I would probably space out your graph a little bit. Like you probably don't want to put 1 here and negative. That's going to be tiny, small. Some of you can relate. All right, small. It's going to be a little bit small. Okay? Too harsh for some of you? Reality? Space it out a little bit. All right, space it out a little bit. 1, 2, 3, 4. 1, 2, 3, 4. You can go down 6, up 6. It's up to you. But space that thing out. All right, you ready? Now here comes the new stuff. Everyone okay with the y-axis? How Cam knew it was 0, -1, and 1. Okay, now here's the new part. Here's the new part. We are not going to have the same x-axis. Don't write this down because it's incorrect. Remember, it always was pi over 2, pi. It was already there for you, right? No, not anymore. It's going to have a new x-axis. How do I know? Does it have a b value other than 1? Does this curve have a b value? Yes, it does. So if the b value is not 1, it's a new looking x-axis. All right, but it is still broken up into 4 parts. So what I need you to do right now on your x-axis, please place 4 equally spaced tick marks. Okay, 4 equally spaced tick. Don't do 1, 2, 3, 4 right next to each other. That's going to be too small of a graph. 1, 2. I space them out the same amount. I don't care what you go by. Everyone's got 4 equally spaced tick marks. All right, here's how we figure out what those tick marks are going to be. Let's talk about the last one. What do we call? What's the vocab term we've been using where that's where a curve ends before it starts repeating again? Yes, period. And you guys know how to find it now, don't you? That will be my last tick mark, will be your period. Here you go. Henry, how do I find period again?
2 pi over b.
So I go 2 pi over b. Henry, what's the b value in this problem?
4 pi.
No, you're doing it to, I'm looking for the b value. What's in place of b?
Oh, 1/2.
1/2. Everyone's good how we know that? We just went over that part. All right, now, Henry, what is the period? 4 pi. That is where this curve will end, which means on that last tick mark goes a 4 pi. See how we got that? The last one is always where it ends, where it starts repeating, and that's your period. All right, well, what about the other 3? We got to cut 4 pi into 4 equal parts. 4 equal parts now, which I'm going to call the rest of the tick marks. I'm going to start calling key values. That's what we're going to call the rest of the tick marks, key values. And you take the period, look, you take whatever your period is and always divide it up into 1, 2, 3, 4 equal parts. Okay, 4 equal parts. So what do I get with 4 pi divided by 4 equal parts? Juliana? Pi. So that's where I'm going to start now. Go back to the first tick mark. I'm going to start at pi and keep adding it every single time. Okay? Keep adding that key value every time. So here's what I'm talking about. Where am I going there? Wes, pi plus another pi. Hey! Plus another pi, Wes. And hey, watch. Wes is a magician here. Another pi. Oh, that's where we ended. Shocker. That's where it should always end. Whatever we discussed, what was the period. We're going to do it again in the other problem, but any question? Because now here comes the easy part. Here comes the easy part. Easy part, maybe. Easy part. Samir, here we go. Am I graphing a sine or cosine curve? Okay. Everyone ready? Everything is all set up for you. Samir, where does cosine start? Max, graph it, everyone. Then where does it go? Midline, which we said was 0. Then where? Minimum. Then where? And then where does it end? You're still, guys, you are still, everything's set up for you. It just doesn't look like the x-axis where you have been graphing on. You still go cosine, min, max, midline. There we go. Just with the new x-axis. Questions from you guys? All good? Questions? Okay, come on. One doesn't make us great. Here we go. Number 2. Set up. Hey, at least get your x, y axes set up and tick marks. Just get your tick marks. I don't need numbers on them yet. Just get your tick marks done. 4 of them, always equally spaced. All right. Let's talk about how to set up the y-axis for this one. Wes told us last problem, hey, every y-axis needs a max, a min, and a midline, which you should get from the equation at this point in the unit now. Those are the only three values I need: max, min, midline. Can you look at the equation there for me and let me know? Sierra, what's my midline going to be? 0. There is no, remember, that's your C value. Everyone, midline is always your C value. There is none. How about my max, Sierra? 1. Yep, there's a 1 in front. How about my min? Yep, I'll change all that on Monday, though. But for now, yeah. All right, go ahead. Put it on your graph. Put it on your graph. Space out those 1s, please. All right, x-axis. Here's the new part for everybody. First is find what the final tick mark is up here. And what's that term called again? Where it ends and starts repeating. What's that vocab word where it ends and starts repeating again? Kaylee? Period. And what is the formula we learned today? Got it. What is the b value in this problem? Good job. Pi over 4. So I'll plug that in for b. You want to tell me what the period's going to be when you're ready? 8. All right. Hey, it is possible you might not have a pi in there. It's going to go out to 8. Now, the other tick marks. Cut the 8 into 1, 2, 3, 4 equal parts. Cut the 8 into 4 equal parts. So where's it going to start then? What's my first tick mark? Grayson? Just 8 divided by 4. 2. It's going to start at 2. And keep going by 2. Okay, over there it went by pi. Keep adding 2 every time. So finish off the x-axis there for me. Miles, keep going. What's the next one? 4. Oh, watch the magic. You add 2 again, you get 8. Always should end at the same spot. All right, good. Thanks, guys. Now the easy part. To me, it's the easy part. Meredith, you ready? What are we graphing? Sine or cosine? Sine. All right, where's sine start? Midline, which we said was 0. Where does it go from there? Max, which we said was 1. Yep. Then? Perfect. Keep rocking. You can teach her. Go ahead. And then? There you go. Those rules don't change. It's just my x and y axes look different. Okay? How are we feeling? New x-axis. Oh, well, I'm not done. I want to go do some of the assignment with you. Let's go 3, everyone. Let's go 3. Let's hit up 3 here. Please don't start doing number 1. Or go ahead, read through, because I got a new word up there that might mess with you. Anybody want to try to pronounce that bad boy?
Sinusoidal.
Sinusoidal?
Sinusoidal.
That everyone thinks that's the sine curve. No, that's just a curve that repeats every time. That's all it is. It's any curve that starts repeating again. All right, it's not the sine curve. It just means a curve that starts repeating.
So these are all sinusoidals?
Yes, correct. Sine and cosine are examples of sinusoidal curves. You like that? Use that today. Equal the period. Oh, what's 18 in this case? What's 18? What's 18?
The period.
The period. Hold on. Juliana, we have a formula for that, don't we? Mm-hmm. What is it?
Period equal to pi over.
A little bit different now. A little bit different. Somebody help me here. Kaylee, a little bit different. What is the period here? Okay, so where does that go in for, Kaylee? In for P. Yeah, everyone. Hey, now I know it. And I'm asking for what's its frequency now? A little bit different. Ooh, how comfortable we are solving this. Instead of going to equations and plugging it into equations, because that's my answer to everything. What's this 18 over?
1.
What can you do now? Cross multiply. Good against, yeah. Cross multiply. Yeah, put it over 1. Ready? 18 times b equals 2 pi. Finish it now. How do I get the b by itself, Sophie?
You divide by 18.
Yeah, be confident. Divide by 18. Plug that bad boy in your calculator and let me know what the b value is, your frequency.
Pi over 9.
Got it. Okay, so sometimes I may give you the period and ask for the frequency in return. All good? Okay, keep grinding away. Go back to number 1. Let's roll.